Alright, here we are with EI Lesson 8, Operations with Scientific Notation. We're talking about addition and subtraction this time. You will probably want to take notes on this video if you are taking notes for the first time. Our objective is to perform operations with numbers expressed in scientific notation, including both decimal and scientific notation usage. We're going to perform operations such as addition and subtraction. We can also do division and multiplication, and I think you'll soon see that it's really pretty easy because of the linearity of the situation. That's fancy talk for you'll like this. It's not that bad. Here's example number 1. We know that the population of New York is approximately 1.96 times 10 to the 7th, and New York City alone is 8,245,000. How many people do not live in New York City? Filling in this, fill in the blanks here. I'd love it if you gave this a shot on your own. So go ahead and pause the video and give it a try. All right, to find the number of people that live in New York State but not in New York City, we must blank the population of blank from the population of blank. We're going to subtract the population of New York City from the population of New York. First, we need to change the population of New York City to scientific notation. New York City is 8.245 times 10 to the, how many times have we moved the decimal? 1, 2, 3, 4, 5, 6. To find the difference, we subtract what? Well, we have to subtract New York City from New York, which would mean 1.96 times 10 to the 7th minus 8.245 times 10 to the 6th. We have a problem though. These are not the same order of magnitude. There's a 7th power here and a 6th power here. We need to convert those to the same in order to make the subtraction work correctly. Here's what this says down here. To find the difference or sum of numbers in scientific notation, it is best to make the order of magnitude the same in all numbers. So each number must have the same base and same order of magnitude. We can rewrite the population of New York State as an integer multiplied by 10 to the 6th, and then subtract. So we'll rewrite this guy as a 10 to the 6th integer, or we could rewrite the other one as a 10 to the 7th integer. It actually doesn't matter. We'll do the 10 to the 6th since that's what it suggests. If we're going 10 to the 6th instead of 10 to the 7th, we need to move the decimal 1 to the right. So we're taking 19.6 minus 8.245. Both of them are times 10 to the 6th, which means we can, for now, just subtract these two integers because they are the same order of magnitude. We could do this by hand if we like, or of course we can use our handy dandy calculator right here. 19.6 minus 8.245. That did not work at all. Let's try that again. 19.6 minus 8.245. This calculator's a little slow, so I have to type slowly. So we have 11.355 times what? Well, that's still 10 to the 6th. And it turns out we can convert that back now to 10 to the 7th, so it's an actual correct and proper scientific notation. So move the decimal 1 to the left and add one more to the exponent and order of magnitude. 1.1355 times 10 to the 7th is our, what's the units? That's people. And that's our result here. Pretty slick. Okay, we'll do a couple more practices and then I will set you loose on the problem set. I'd love it if you did this problem set on your own, but please keep in mind that this is a sticking point for a lot of students. So some of you might get stuck a little bit on here, and that's okay. You can come back to this video and I will walk you through the process. All right, so to add these together, we're going to convert them to the same order of magnitude first. I am, by convention, going to convert to the larger order of magnitude. There is no rhyme or reason for that. You can convert to the smaller one if you like, but I'll take this 10 to the 5th and turn it to 10 to the 6th. That is 0.12 times 10 to the 6th plus 5.35 times 10 to the 6th. If we add the 0.12 to the 5.35, we get 5.47 times 10 to the 6th. And I actually lied to you. There is a rhyme or reason for this. The reason that I'm converting up is because then I don't have to reconvert when I've completed the addition. If we were subtracting, perhaps we might consider converting down, depending on where the numbers will end up. Okay, so 8.41 times 10 to the negative 5 subtracted by 7.9 times 10 to the negative 6th. We're taking a bigger number, subtracting a smaller number. So we're going to convert the smaller number to the higher order of magnitude, this guy on the right. This is really 8.41 times 10 to the negative 5 minus, we need to go a higher order of magnitude here. So we're going to add 1 to the order of magnitude. And this brings up a really good question. How do you know which direction the decimal is going to go? Going back to this guy, I knew that when I went to the left, my order of magnitude became larger. So we're going to write a general rule. This would be really good to have in your notes. As the decimal goes left, the magnitude order, or the exponent you could call it, goes up. Decimal goes left, exponent goes up. Okay, as the decimal goes right, this is a different idea. I probably should have done it in a different color. As the decimal goes right, well, what happens? The exponent goes down. Let's test that theory. Here we have 300.76 times 10 to the 4th. If we want to convert that to scientific notation, we're going to move the decimal left twice, 1, 2, which means that this needs to get bigger. According to this formula, the decimal goes left, the exponent goes up. So this is 3.0076 times 10 to the 6th. Let's see if this actually makes sense by converting these both to standard form. 10 to the 4th means move the decimal right 4 times, so we have 300.7600. And the same thing here, except we're moving the decimal to the right 6 times, and I think you can see that those are in fact the same thing, so we've done this correctly. Oh, that's a little off the screen there, I'm sorry. There you go. You can see that they're the same thing. Okay, so let's do the next two and call it quits for this section. We have 6.91 times 10 to the negative 2 and 2.4 times 10 to the negative 3. This guy is smaller because the negative 3 suggests the decimal moves further. In order to convert, we're going to, just like the last one, we will, which we didn't finish. There's ADD for you. Let's go ahead and finish the last one first, and we'll come back to letter B here. This is letter E. For no reason, it's letter E instead of letter C. We have 8.41 times 10 to the negative 5 minus, I'll write it like this, minus 7.9 times 10 to the negative 6. We're going to convert this to the negative 5 here. And as the exponent goes up, the decimal goes left, according to the rule I just wrote down. So this is 0.79 times 10 to the negative 5th. Now we subtract these as normal. I'll use a calculator to get it right. 8.41 minus 0.79 is 7.35 times 10 to the negative 5th. And we're done. Same thing here, except now we're going to convert, since we're adding, to the bigger decimal, the bigger magnitude, so that we're going to convert to 10 to the negative 2, because 10 to the negative 2 is bigger than 10 to the negative 3, as far as magnitude here. Okay, so we have 6.91 times 10 to the negative 2, plus, how do we convert this to a negative 2? We need to move the exponent up, which means the decimal needs to go left, according to our rules over here. So 0.24 times 10 to the negative 2. Add those together, and we get 7.15 times 10 to the negative 2. All right, and the last one, we have 1.33 times 10 to the negative 5, 10 to the positive 5, excuse me, subtracted by 4.9 times 10 to the 4. Now this is actually a bigger number here. this is actually a bigger number here. So we're going to convert to that order of magnitude so that we can stay in the higher order of magnitude. We're subtracting 4.9 times 10 to the 4. I want that exponent to go up. Once again, that means the decimal goes to the left. So this is 0.49 times 10 to the 5th. Subtracting 1.33 minus, we could just do 0.5, which would be 0.83. We'll have one more to get 0.84 times 10 to the 5th. Now this is not proper scientific notation, so we're going to convert that by adding another or subtracting an order of magnitude. That's not said correctly. We're going to convert this by shifting the order of magnitude by 1. That's a more proper way to say that. If you need help with these problems, I will not be making a video on these. You can go ahead and type these into Google if you are desperate to get help. Google will help you. You can use Wolfram Alpha or other programs like that to test your answers, but I suggest that you give this a try and we will grade it in class.